Hi Bio20, welcome to the final topic for the excretory system. This is about how hormones regulate the amount of water that gets reabsorbed and a little bit about some excretory disorders. Now, the first hormone we'll talk about is ADH, and that's antidiuretic hormone. And this is a hormone that is released when you are dehydrated. And the hypothalamus of the brain, which is located right about there, is sensitive to dehydration. And in fact, it shrinks if you are dehydrated. And what happens is ADH, antidiuretic hormone, is produced by the hypothalamus. And it's actually stored over here in the, we'll try that again because that line went kind of funny. It is, we'll try a different color. It is produced in the hypothalamus, but stored in the pituitary gland. And when the hypothalamus is dehydrated, the pituitary will release that ADH into the bloodstream. And the shrinking of that hypothalamus gives you the sensation of thirst as well. And so it's called an osmoreceptor. But what happens, you could be dehydrated or you've sweated a lot. And what happens is when that ADH is released into the blood, it affects two parts of the nephron. It will make the distal tubule and the collecting duct both reabsorb water, and that means the water will be taken back into the surrounding bloodstream. As you recall, the nephron is surrounded by a capillary network, and so because of antidiuretic hormone, those two locations are where water will go from the distal tubule and collecting duct and back into the bloodstream. And that will be the effect of ADH. ADH is a hormone. It is something that will travel through the blood and have that effect. What happens then is your blood will be more diluted with that water, and it will send that message back to the brain that it doesn't need any more ADH release. So this is the chart that talks about what happens if you have too high of body fluids, too concentrated, and you're lacking water. Then you're going to have ADH release, and when you have water back in your blood, it will stop that release. And a diuretic, the opposite to antidiuretic, a diuretic would be something that doesn't make you keep water. In fact, it would cause you to lose water. And so you may have heard of alcohol or caffeine being described as diuretics, and that means that they would cause you to lose water and be dehydrated, whereas antidiuretic hormone is causing you to reabsorb water. Okay, second mechanism we'll talk about is the effect of a second hormone, also starts with the letter A, and it's called aldosterone. And aldosterone is what they would classify as a mineral corticoid. So it is something that causes minerals to be reabsorbed, specifically sodium and potassium. And when you have low blood pressure, that's the stimulus for aldosterone release. Aldosterone is released from your adrenal gland. If you look at your kidney right here, the adrenal gland is a gland sitting like a little mountain on top of the kidney. So that's where it is. And that is where aldosterone is released. And the adrenal gland, you may also have heard of adrenaline. That's another hormone that comes from the adrenals. But today we're just talking about the aldosterone that comes from the adrenals. And what it will cause is it will cause sodium to be reabsorbed from the distal tubule and collecting duct. So when we draw our nephron, it's those same two locations, distal tubule and collecting duct, that we're talking about. And sodium is going to be reabsorbed into the bloodstream. Of course, chloride will follow the sodium to make sodium chloride. And what happens when the blood is, think of bloodstream being salty, then water is going to be reabsorbed as well, because it will follow the salt and try to dilute the salt, and basically you've got reabsorption happening that way. So this is so important to reabsorb water that you've got several mechanisms at play. You've got ADH that causes water reabsorption, because it basically will open the pores of our nephron tubules. Or you've got, you've got aldosterone that causes the sodium and reabsorption and chloride. So that is a second way that water balance is monitored. A third mechanism that involves water balance is how our body continues to be homeostatically at a 7.4 pH in the blood. And that's just a little bit on the basic side. But basically this involves the mechanism of how the bicarbonate ion is traveling through your blood, and that's how carbon dioxide is carried, is by bicarbonate ions. But the amount of bicarbonate and hydrogen ion that's in the blood is really a way that your body regulates how much hydrogen ion it carries, because that will determine how acidic the blood is. So this whole process was discussed in chapter 7, and we just bring it up here because it is a way that your blood is continually in that 7.4 pH. But also, it's also mentioning that the kidneys have a role, because if you have too much hydrogen ion and it's too acidic, then the kidneys actually excrete the hydrogen ions and put them into the urine. And they can also keep bicarbonates if they need them for maintaining a proper pH level. Okay, that brings us to some excretory disorders. And all of these are explained in your book if you have that, but I also type them into the notes in case you don't have your book to refer to. The term diabetes is often something that is used just by the word by itself, and that refers to a different diabetes, the diabetes mellitus that people have in terms of having trouble monitoring their blood sugars. Diabetes insipidus is different. Diabetes insipidus is when you have a low amount of ADH and you're not reabsorbing water. So the word diabetes is actually related to dehydration, and someone with diabetes insipidus, because they don't have the hormone ADH keeping water, they lose a lot of water. And that's the extreme thirst results, and that's the symptom that could tell you that it's diabetes. If it's a blood sugar problem, it would be diabetes mellitus. If it's a problem with your ADH level, it would be diabetes insipidus. UTI is urinary tract infection, and this could be anywhere in the excretory system that's inflamed. The word cystitis could happen because of a bladder infection. Urethritis would be infection of specifically the urethra. Kidney stones, like you see here, these big stones lodged in the renal pelvis of the kidney. Looks very painful, but if you're not consuming enough water to wash out the kidneys and keep the urine flowing, that's one problem, is that the components of the urine start crystallizing, and that is one of the causes of kidney stones. Renal insufficiency is when there's problems with keeping the nephron healthy, and I list a whole bunch of possible reasons here that could cause renal insufficiency. And basically you're not cleaning out the blood as the normally healthy kidney would do. Gout is high uric acid in your blood, and this causes these little crystals of uric acid to give a lot of pain, like in the feet, and they say that if you consume a very high amount of uric acid, like in organ meats and maybe these other things, herring, mushrooms, asparagus, I suppose that is a potentially high source of uric acid. They also mention here that high alcohol use may be a factor, and so does high blood pressure, and also use of certain medications. And so there's a lot of different things that can cause that. The word dialysis, to wrap up today, is the method that blood can be cleaned if your kidneys can't do the job, and a dialysis machine can clean the blood. This is a life-saving technology that is used by people with kidney disorders, kidney dysfunction. And what happens is the blood goes into a solution called dialysate, and that dialysate, because it has no toxins, will cause the diffusion of the toxins that are in the blood to go into that dialysate. And I will show you how those work in our diagrams in a moment. But hemodialysis means that you're connecting your the cleaning will happen because it's connected to your artery, whereas peritoneal dialysis means that there's fluid that's being put into the peritoneal cavity, basically your around your internal organs, your intestines, and because that fluid is clean, your toxins will flow into it, and then that fluid gets drained. So that's a second type of dialysis. So I'll show you those, I guess, before we talk about transplants. So the first kind here, the hemodialysis, the person's artery would be sending the blood with a higher pressure here into your dialysis machine, and as it's flowing through this clear fluid in here is the dialysate, and what happens is all the toxins in the blood will flow out into that dialysate. The dialysate is drained off so it can keep replenishing it with clean dialysis fluid that's pumped in with the pressure, and when it goes back, it usually goes back into the body nicely warmed and now clear of any toxins. This is what the real machine looks like, the dialysis machine. And the other type, peritoneal dialysis, is when this fluid the dialysate is pumped right into the peritoneal cavity and stays there for a number of hours. It's up to 12 hours, and then drained out, and by that time all the toxins that are in the blood would have diffused into that dialysate solution. So that's just a second type of dialysis. There's also the night dialysis machines where instead of sitting hooked up to the dialysis machine for 3 hours at a time, you can have it put on every night and have it cleaning the blood over the night, through the night. And the main problem with now 80% of the people waiting for any organ transplant, 80% of the people are waiting for kidneys. This is, for some reason, a very high demand organ, and with kidneys failing, it is one of those things that could be fatal because those toxins those urea, uric acid, and ammonia cannot build up in your body because they are poisonous. The reason that there's issues with transplants is that organs from other individuals will naturally be rejected by your body, so the person has to be a close tissue match, similar proteins to the donor. They will have to be put on anti-rejection medication, and we have the issue where the little tiny parts of the kidney with a high pressure, like the glomerulus, are easily damaged by certain health conditions, including really high blood pressure. So this is one of those organs you need to take care of. Okay, we are just this last one. It says that success rate is pretty high for kidney transplant. And when you're on anti-rejection medication for the rest of your life so you don't reject that kidney, that means that you're suppressing your immune system. So that is, one drawback of receiving an organ. However, it is a life-saving surgery. And they mention that they can remove a kidney by laparoscopy. A live donor can give their kidney, donate their kidney, and survive with one kidney just fine. But the person receiving that kidney, who spent years probably on dialysis, will find that it's a life-changing thing to receive one kidney. One kidney will do the job of all of the blood cleaning that it needs to do. So the pretty cool system that we have two kidneys and really can survive with one. Okay, super great. Oh, by the way, that's polycystic kidney. That if you ever hear of that, cysts that form on the kidney. That's what that looks like. Super great review videos here. One that I always show my students is the 3D printing of a kidney. That's a possible future technology that could be more widespread. This is a TED Talk of a boy who actually received a kidney that was 3D printed. So you're using your own cells, so there's no tissue rejection like normal transplants have. So a really well worth